Okay, so in this lesson, we're going to learn how to find the area under a curve using a trapezoid instead of a rectangle. But the first thing I want us to do is remember what a trapezoid looks like. And so a trapezoid is a four-sided figure with one pair of parallel sides. And here I've drawn a trapezoid that's laying on its side. This would be the height. These two would be your bases. In our graph, you'll see that the trapezoids are standing up instead of laying down. But the formula for finding the area of a trapezoid is 1/2 times the height times the sum of the two bases. So I'm not going to necessarily read through all of this for right now. I'm just going to go ahead and get down to the example. Let me get my page turned better, sorry. So we're going to approach this the same way that we would if we were using rectangles. This says use the trapezoid rule with n equals 4 to estimate the area under the curve y equals x squared from 1 to 2. So what this is telling us is we want 4 trapezoids. So what we need to do first is we need to determine what is this constant value between all of the trapezoids. And in this case, these would be considered the heights, whereas with a rectangle, we would have referred to those as the widths. But that's really just irrelevant. We need to determine what that value would be. And so we're going to use the same approach where we would take b minus a and divide it by n. Our b value is 2, our a value is 1, and n is 4, and that reduces to 1/4. So what that tells us is that each of these lengths right here are 1/4. So there's a constant 1/4 to all 4 of those trapezoids. So if we apply finding the area of each trapezoid, this is what it would look like. Okay, so the area of T1, I'll call that trapezoid 1. We would find that by taking 1/2, multiplying it by the width, which is that common 1/4, and then I would, I would determine each of the bases. And this is where we approach this the same way we would have approached finding the height of the rectangle. So I'm calling this would be our base 1. And if I want to know the length of that base 1, I would simply take that value and substitute it into our function to give us that value. So this is at 1, and so this would be 1 plus, now I need to figure out, actually it's 1 squared, plus that next endpoint would be 5/4. So that would be 1 squared plus 5/4 squared. And that would give us, now, that would give us the area of the first trapezoid. All right, so here's what I also need to point out though. One of the things that I did, or that we did, was we actually would go through and find the endpoints first. We'd kind of get all that little nasty, tedious stuff out of the way first. So let me go back and do that real quick. My endpoints. Since my interval starts at 1, and then each trapezoid has a height of 1/4, my endpoints will be 4/4, because that's 1, 5/4, 6/4, 7/4, and 8/4. So that starts at 1 and ends at 2. So let me go back and just re-comment on what I did here. So for me to find the height, or the value of each of these bases, I'm going to do so by plugging in each of these endpoints into y equals x squared. So that means I'm going to be determining 4/4 squared I'm going to determine 5 over 4 squared, 6 over 4 squared, 7 over 4 squared, and 8 over 4 squared. Okay, so that's how I'm going to find these lengths right here. So now going back to our first trapezoid, finding the area of the first trapezoid, then when I substitute 1 in for the function to get the length of that base, that's going to give me 1. And I know this is too messy for me, and I don't like the way I like that I've written that. So I'm going to have 4 over 4 squared, which is 1, plus, and actually, and then 5 over 4 squared is going to be 25 over 4. No, it's not. 25 over 16. And so knowing that my denominators are going to be 16, I think I would rather look at 4 over 4 squared as 16 over 16. So once again, I'm going to go back here, and I'm going to make that 16 over 16 plus 25 over 16. Okay, now I'll do all the calculations in just a few minutes. So now that maybe I've got my act together, for trapezoid number 2, I would have 1/2 times the height, which is still going to be 1/4. And this time, the base 1 for the second trapezoid is the 25 over 16. And I need to add the second one, which is going to be 36 over 16. For trapezoid 3, the formula is 1/2 the height. And again, the height is 1/4. And the base 1 of trapezoid 3 is going to be this one, which is the 36 over 16 plus this base, which is going to be 7 over 4 squared, which is 49 over 16. And finally, we get down to 8 over 4, which is going to be 64 over 16. So trapezoid 4 is going to have an area of 1/2 times 1/4 times 49 over 16 plus 64 over 16. That's kind of messy, so I'm sorry. So make that a little bit nicer, maybe. And make that plus 64 over 16. Okay, so one thing I want you to look at in all of these, notice how the 25 over 16 repeats, and then 36 over 16 repeats, and 49 over 16 kind of repeats. And it's not so much that they repeat, it's more that each trapezoid is sharing a side. So taking this information here, and if I'm going to pull this down, if we look at the formula that I've provided here, when you're trying to find the area under a curve using a trapezoid rule, then you can, instead of doing this individually like this, you could write it as T, or the area using the trapezoid approach or rule, is 1/2 the height, because all of them have the same height of 1/4. And what you can do is you can take you want to find the sum of all these the sum of all the bases. Well, there's only going to be one of these, so that's going to be 16 over 16. So there's only one of the first base. Then there's 2 of the second ones, so it's going to be 2 times the 25 over 16 plus, then you have 2 of the 36 over 16, so 2 times 36 over 16 plus you have 2 49 over 16s, and then you have 1 64 over 16. So that's just an abbreviated way. Instead of writing all of the formulas out, or writing the formulas out 4 times, this is just an abbreviated way, since we know that we're going to have multiple trapezoids. So now let's think about what all of this turns out to be. So we're going to have here a 1/8, because the 1/2 times 1/4. And then I'm going to have, I need to get my glasses on, 1/8 of 16 over 16 plus 50 over 16 plus 72 over 16 plus 2 times 49, what is that, 98 over 16 plus 64 over 16. Kind of run into that. Then it's a matter of just adding all of these up, multiplying it by 1/8, and so this is what that's going to look like. We have 1/8 times, the numerators are going to add up to be, I believe, 300, and that's over 16. And that's going to be approximately, make sure you use your approximately, excuse me, goodness, 2.344. So the area under the quadratic between 1 and 2 is going to be approximately 2.344. And of course, we don't have any units with this. But that is how we can use the trapezoid rule to find the area under a curve. So we'll stop here, and I will finish out this lesson with a second video. So just go back and look through this, go through this again, make sure we understand all the little details.